All right, so we're going to look at another example of hypotheses testing. This time again, I want to go off a similar problem from homework. So I'm going to pull that up first. And I don't want to read the whole thing yet because I'm going to import it into the other document. But first, let's just look at the questions it's asking. Select the correct null and alternate hypotheses. So we'll do this after we've figured that out on the other side, getting the claim and its opposite. That'll enable us to find the null hypotheses, which is always the one with the equal sign, and the alternative hypotheses, which is the one, I guess, that does not have the equality. So when we try to decide which of these we're going to choose, I think I misspoke in the previous video. We actually find the correct alternative hypotheses, and then the null hypotheses. Notice in all of them has equality in these examples. Okay. Then it wants us to find the p-value and round it to 3 significant figures. So what that means is the zeros to the right of a decimal point don't count, and we want to have 3 non-zero digits to the right of the decimal point. Okay, and then determine the final conclusion. So we've been doing that already. And then it asks some questions about the type of poll that's being done here. So switch over. I've copied the problem here. It says a research group suspect that less than 49% of, oh, this is the wrong problem, sorry. I changed the problem, so we'll copy this out. I didn't change it, but when you log back into WAMAP, it changes it. And to tell you the truth, I've actually already done this problem once in a video, but it took half an hour, and I made a mistake, so I figured it's better to redo it correctly. Hopefully it won't take quite as long. It's not bad to see that I make a mistake too for you, but I hate to sort of have you following along and not see the mistake. So I'll show you in this video where I have made a mistake previously, and hopefully you can avoid that type of mistake yourself. A research group suspects that less than 45% of Americans support the Republican presidential candidate. To test this claim, so what claim? Less than 45% support the Republican candidate. They randomly call Americans until they get 1,000 responses. So that's our N. I need to move this down a little bit. And I don't know what happened to my pen here. I went to rainbow color. I want black. So my N is 1,000. And of the 1,000 people who responded, 416 said they support the Republican presidential candidate. So that's X, the number of successes, or the number of people who said they supported a Republican candidate, 416. It says, test the research group's suspicions. So notice there's no mean given in this problem, and there's no standard deviation given in this problem. So this is a hypotheses test about the proportion. So we need to find p hat, and that's always x over n, and that's 416 divided by 1,000. And then, because we're just dividing by 1,000 here, there will be no rounding if I convert this to a decimal. So I'm going to convert that to 0.416. Notice that the significance level is not provided. So when alpha is not given, we assume that it's 0.05. That's the default. Okay, so what is the claim? We look at the hypotheses. The claim is that less than 45% of Americans support the presidential candidate. So the claim is that the population proportion that support the Republican candidate is less than 0.45%, or 0.45. I want to identify the opposite of that. So that's p is greater than or equal to 0.45. only one of these two will have an equal sign attached to it. And that equality one is the one that is our what we call our null hypotheses. So some textbooks consider this to be the null hypotheses. Other textbooks consider just the one with the equality to be the null. So if you look at the homework, it just has the equality. I actually misspoke on that, I think, in the last problem, but that's okay. That's our null hypotheses with the equality, and our alternate hypotheses is the other one. The alternate hypotheses determines the type and the number of tails. So our picture, we have the standard normal distribution where the center here is 0, the mean is 0, and the standard deviation is 1. And then because the alternate hypothesis is a less than, that is a left tail. And the area in that left tail is alpha. One tail, so it has all the alpha area, 0.05. So that's going to help us find the critical value Z alpha. I'm going to scroll down. To find that Z alpha, we're going to use Excel. So the Z alpha, button. Z alpha equals, I know the area to the left, so that's norm. It's a standard normal distribution. So norm.s, since we know the area and we want to find the score, we use norm.s.inverse. And we're just going to put that area to the left in there, 0.05. Plug that guy into Excel. And you can move that over a little bit so you can see it still. Equals norm. So there's norm.distribution. I don't want that one. I want the standard normal distribution, which is the same thing, except the mean is 0 and the standard deviation is 1. So it's our z-scores, 0.05. Oh, and the cumulative value here again is true. I left that out of my thing on the board. And that is a z-score of 0.52. That does not feel right to me. So I'm going to pause for a moment. Oh, I did normal dot distribution. And why do I know that's not right? If I look back at the picture here, I just want to show you, 0 is in the middle. That Z alpha has to be a negative number because it's to the left of 0. So what I did was I didn't punch in the right function. I punched in norm.distribution, and I meant to punch in norm.s.inverse. And there is no true here. I was wondering, it's not actually there. It just wants the probability to the left, which is 0.05. And I'll click on that guy and tab out of here. Oh, shoot. Sorry. Tab out of there, negative 1.64, and this is actually the one. There's two values that we round to 3 decimal places, and this is one of them. So negative 1.645. It's my z-score. And that's my critical value, 1.645. And why is that one rounding to 3 decimal places instead of 2? It corresponds in the last chapter to a 2 tails, and that would be 90% in the middle. So that's that same value corresponding to that 90% confidence interval, because confidence intervals always have 2 tails. Hypothesis test, in this case, has only 1 tail, left tail. They can have 2 tails, but this one only has 1. So negative 1.645 is our critical value. And I'm going to come down here and calculate my test statistic and determine whether or not my test statistic is inside this tail. to the left of negative 1.645. So my test statistic equals, here's where I made my mistake last time. P hat, I just typed it in wrong. It's 0.4, scroll back up, 416. I had used the wrong number here, and then I spent 30 minutes trying to figure out what happened. Minus P, so P comes from our null hypotheses right here, 0.45. Or you can also just look at it over here. It's the one with the equal sign on it. P is 0.45. So P hat is the sample proportion, and P is the population proportion. Pen is protesting. There we go, 0.45. I'm dividing that by the square root of P times Q. So P is 0.45. Q is 1 minus that, so 0.55. That's all under the square root, all divided by n, and n is 1,000. So when I type this into Excel, what I want to do is do it all at once. So equals the numerator I put in parentheses, 0.416 minus 0.45, close that parenthesis off, divided by, type in square root. This will capture the whole denominator. So I don't actually need any parentheses downstairs because I'm going to go 0.45 times 0.55. It will do that multiplication first, and then it will divide by n, 1,000. So I can enter it all in at one time, tab out of there, and then that's not a special value, so I would normally round that to 2 decimal places. Negative 2.16 is my test statistic. And so if the problem was asking for that, we would enter it into the homework question. It's not. I generally will ask for it. But where is that up here? That's to the left of this guy. So that lies in the tail. So once we know that, we can look for our conclusion. The problem here also wants the p-value, so that's the 5th step. But first, let's get our conclusion and make sure we finish the problem. So the conclusion comes from, again, I can look at the PowerPoint, which I've closed. I'll pause for 1 second. Okay, so in the PowerPoint, I know that my test statistic lies in the tail. So I'm going to go to the last page of the PowerPoint. It gives us these general conclusion results. If the test statistic is in the tail, which it is, then the evidence rejects the null hypotheses. I'm just going to copy that out of there, paste it in over here. Evidence rejects the null hypotheses. I now want to check whether that null hypothesis is my claim or not. That's upstairs here. So the null hypothesis was not my claim. The null hypothesis was the opposite. So my claim was actually the alternate hypotheses. So I have to switch to the other statement, which is the one right below it. So I go back to that last page. I grab that sentence right below it. Just copy that out of there. Paste it in. The evidence supports the alternate hypotheses, and that's my claim. And in our conclusion, we could type this out, would say there is evidence, or there is sufficient evidence to support the claim. Dot, dot, dot. What is the claim? To go back up, maybe look at it again. Less than 45% of Americans support the presidential candidate. Oh, let's claim that less than 45% of Americans, 45% support Republican candidate. Okay, so that part's done. The problem is actually done, except that the problem on the homework is looking for the p-value to 3 significant figures. So the p-value is the area in the tails that is more extreme than the test statistic. So because we're looking for proportion, we're doing a hypotheses test of the proportion, we're using norm.s.distribution, and I need to just plug in my test statistic here. So my test statistic again was negative 2.16. In the picture, the p-value represents the area in the direction of the tail or tails. So here's my negative 1.645. And over here is my test statistic. So if I'm in the direction of the tail more extreme than negative 2.16, it's the area to the left of this. So it's not very much area. So it's good to have an idea of what the answer will come out to be, meaning is it big or small, because sometimes we type stuff into Excel incorrectly, which you just saw. So I'm going to go here equals norm.s for standard normal distribution, dot distribution. And since I have this value of negative 2.16 right here, I'm just going to click on that so I don't use a rounded value. I use an exact value here. And then comma, the cumulative choice is true. Pretty much always for normal distributions for us. Okay, and we'll tab out of there. So it wants 3 significant figures. So the zeros in front here are not significant. So we just ignore them, and we need 3 more digits in addition to those zeros. 153 it looks like. So 0.0153. 0.0153. That's my p-value. And then we're asking if that's bigger or smaller than alpha. So alpha was 0.05. So in this case, that p-value is less than alpha. And just so we can look back at our PowerPoint for a second, you know, when the p-value is less than alpha, that's up here. So those same conclusions we already got. This is just an alternative way to get the answer. So we don't have to restate this. We've already done that. We can just go back to here and maybe just recognize that that is the same as these solutions up there. Okay, so heading back over to WAMAP. So I would suggest that you kind of do these whole problems out first. That will give you the practice that you need on paper to be able to complete the tests, the problems on the test next week or week after next, week after next. And then click back into WAMAP here and put the answers in the right corresponding spot. So here we're trying to figure out which of these is correct. So we can base that on our alternate hypotheses. So our alternate hypotheses is that p is less than 0.45. It's not that one, it's not that one, it's not that one. Here it is. P is less than 0.45. And our null hypothesis is that p equals 0.45. So again, you could think of that as your null hypothesis. You can also think of the other one over here as your null hypothesis. The problem will remain the same. Scroll down in the WAMAP, they're then looking for the p-value. So that was the last thing we found. 0.0153 to 3 significant figures. So we don't count these first 2 zeros. We need 3 non-zero digits there. Write a final conclusion using everyday language. So let's go back to what I have. There is sufficient evidence to support the claim. They all look the same, so you have to be careful. There is sufficient evidence to support the group's suspicion. Here it is, second one down. And then we'll notice this last one, this is specific to this problem. It's talking about polling, and so this really is stuff back from chapter 2. It says, what are some of the aspects of this poll that might bias the results? Is 1,000 too small of a sample size? No, 1,000 is quite a large sample size, so that's not a problem. If the candidate is controversial, responders may wish to remain anonymous. That is true. Phone and email surveys are susceptible to non-response bias. I'm busy, I hang up the phone. That is also true. The sampling is voluntary and not simple random. That is also true. So those 3 things actually would cause this poll to be biased. And then we'll submit, hopefully, if I can get that on my screen here. It's like a trick question. Can't submit yet. Why can't I submit? There it is. Okay, submit. And I'm just doing this to make sure we get them right. Last time I got it wrong. Hopefully this time it's right. Yay, it's right. So these problems actually, because there's so many parts, I'm actually giving more chances down here, but that, it doesn't necessarily make it easier. That actually makes it harder. So instead of getting 3 chances for each problem, for most of these you get 5. It's because if you make a little tiny error somewhere, there's so many different pieces. So hopefully that gives you a good jump on some of these problems. I'll just peek at the next one, or the next few here. Pretty similar. In fact, it's exactly the same type of problem, I think, all the way down. Find the p-value, find the p-value, find the p-value. All these are the same. Except for the first one's a little different. It's more like what we did in 9a. It's the whole previous stuff, finding the test statistic and finding the p-value. So the only one that I haven't looked at in terms of the videos is the two-tailed test. So I do have an example of the two-tailed test on one of the PowerPoints, if not both the PowerPoint presentations, and I may try to put together another video for a two-tailed test as well.